Hey everyone, we are going to go ahead and start with the notes from Thursday, 5.2. It was properties of rational exponents and radicals. Now, when we're looking at these notes, there's two pieces of information I'm going to be referring to. For examples numbers 1 through 5, I am going to be looking at the properties of rational exponents. When we get through 6 through 8, I'm going to be looking at properties of radicals. So what's the difference between a radical and a rational? Well, a radical is going to have a radical symbol. So it will look like have a base underneath called the radicand. It'll have the root written up here really small. And it could also have a power. Today's, though, will look more like this. It will not have an extra power on the outside. A rational will have a base with a fraction exponent. Alright, so for number 1, we are going to be using properties of rational exponents, and we are going to be using the product of powers on this first one. So with a product of powers, we get to keep the base as long as the base is the same. So we have 7, and then we add the exponents. So 1/4 plus 1/2. Now, before we can add the exponents, because they're fractions, they need to have a common denominator. So their common denominator would have to be 4. So that would give me 7 to the 1/4 plus 2/4. When I add those together, that gives me 7 to the 3/4 power. Alright, on number 2, this one is a power of a power, where we have a power on the inside of the parentheses and a power on the outside. When we have that, we multiply the exponents. So on this one here, I'm going to have 4, and I'm going to do 1/3 times 2/5. So I'm going to do 1 times 2, 3 times 5. So that will give me 4 to the 2/15 power. Now, number 3 does look like a power of a power, which it has that property built into it, but it is also a power of a product because there is multiplication happening on the inside. So I'm going to take the exponent on the inside and multiply it to the exponent on the outside. Once I do that, I'm also going to do that again. Sorry, trying to erase that. I'm also going to do that again, but I'm going to be doing it for this power and this power. So we're going to do that process twice. Okay? So the first time, I'm going to do 4, and then I'm going to do 5 times negative 1, which is going to give me negative 5. And then this 5 has a denominator of 1, so I'm going to do, they both do, for the 3 and the 4. So then I'm going to take that 1 and multiply it by 5 on the denominator. So that 1 times that 1. So that's negative 5 over 5. Okay, let's do that again for 3. So I have 3, and then I have 5 times negative 1, which gives me negative 5, over 1 times 5, which gives me 5. Now I'm going to simplify those fractions. So I have 4 to the negative 1 power times 3 to the negative 1 power. Now we cannot have negative exponents. We talked about that using the negative exponent property. If I move them from the numerator to the denominator, the property then becomes a positive exponent. So I'm going to have 1 over 4 to the first power times 3 to the first power. I can simplify the denominator, so that will give me 1 over 12. Okay. Alright, so then I finished up with those ones. And now let's look at number 4 and number 5. Now Now, number 4 is a quotient of powers. When we have the same base on the numerator and the denominator, we're going to subtract the exponents. The 5 in the numerator has an exponent. It is 1, and if you want that to be a fraction, it's 1 over 1. So when we have a quotient of powers, we subtract the exponents. So I have 5, 1 over 1 minus 1 over 3. Now they need a common denominator, so their common denominator will be 3. So that's 5 to the 3/3 minus 1/3. And that simplifies to 5 to the 2/3 power. Alright, the last one for the properties of exponents, we're using that part of the table. On this one here, I am using the quotient of powers within, and then I have a property where I have an exponent on the outside, so I'm going to use power of a quotient. So I'm going to take everything on the inside for that exponent and multiply it to this. Once I do the numerator, I'm going to do the same thing with the denominator, 2/7 times 1/2. So for the numerator, I will have 11. 5 times 1 is 5. 7 times 2 is 14. Divided by 11. 2 times 1 is 2. 7 times 2 is 14. And now I'm going to go ahead and use a quotient of powers where I subtract the exponents. So try to put a 1 there. And since their denominator is already the same, we can just subtract them. So that I have 11. 5 minus 2 gives me 3 over 14. Alright, so that is it for my rationals practice. So if you wanted to stop the video here and go to the back side and do number 1 through 5, you can. Or we can finish up with this video and you can come back to it, either one. Now what I'm going to be looking at is the property of radicals. So I'm going to be looking at this section here using these properties. Okay, there's a definition and there's an example. Alright, so on number 6, I am making sure that first they both have the same index. If they both have the same index, we can place them together underneath a common index. So I will have third root of 12 times 18, which gives me 216. And I want to take the third root of 216. That's going to be positive, and that will give me positive 6. On number 7, I'm going to be taking the quotient of 2 indexes, so we're going to be taking these 2 and placing them underneath a common root. So the fourth root, I have 80 divided by 5. That gives me the fourth root of 16, and the fourth root of 16 is 2. Alright, on number 8, they both have a fifth root. So I'm going to go ahead and place them under the fifth root. 4 times 8 makes 32. The fifth root of 32 is 2. Alright, please complete the back side of this worksheet and then upload that to Canvas.